Hi guys, so welcome back sa ating YouTube channel. So in this video, pag-uusapan naman natin yung properties of a line of line integral rather. So let's have the properties. So for number 1, for line integrals of a real valued function, so let's say that is a scalar field. So again, yung f na naka-bold tapos something na ganyan yung pagkaka-spell, that is a vector field. Yung real valued function ang tawag is scalar field. Okay, so the line integral ng f of x comma y along the arc length with respect sa arc length along the curve C is just equal sa line integral pag ninegate ko yung C or ninegative ko yung C. Ano ibig sabihin ng naka-negative yung C? Meaning, kung positive C, meaning counterclockwise yung galaw, kunyari clockwise direction, pag negative C, counterclockwise. So, may term dito na traverse. So, yung movement ng curve. So, the traverse means yung movement ng curve. So, for example, traverse counterclockwise, that is a positive oriented. So, traverse clockwise. So, traverse counterclockwise, positive oriented siya. Traverse counterclockwise, that is negative C. So, clockwise direction naman siya. So, dito, mas pinapriority natin is yung traverse counterclockwise. So, kasi yun yung positive oriented natin dito. So, ang sabi lang naman dito for number 1 property is something na kunin ko yung integral, baliktarin ko man, pagpalitin ko man yung position, kumbaga kunin ko yung integral papunta doon. So, ano ba ibig sabihin, no? Point out lang naman nito, no? So, kunyari, kunin ko yung integral papunta doon. So, papunta dito. Equal lang yung pag kinuha ko pabalik. So, whether pagbalikin ko, so, pero may epekto, syempre, ini-negative ko yung traversal niya, o yung movement. Ini-negative ko rin, syempre. Since negative yung curve ko, negative din yung mga values ng parameter ko dun sa loob. Okay, magkakaroon ng konting pagkaka-negative. So, it's either magkakaroon ng konting changes. Okay, so, okay, magalang, din naman i-change yan. Hindi ko naman kayo pipilit na, okay, paki-traverse to clockwise. Hindi naman ganun. Usually, given na siya, it's all about understanding anong klaseng direction siya, kung clockwise ba or counter clockwise. So again, that is for scalar field. So now, for line integrals of vector field, ito ay mayroong epekto. Again, for line integrals of vector field, ito ay may epekto. So sabi nga, ito ang kanyang integral. So ang formula natin ng line integral ng vector fields is just ito. So the integral, so pag tinreverse natin siya or nagkaroon ng negative direction, yung curve natin, kumbaga ibang direction, that is equal sa negative C. So nag-negative, so gusto mong tanggalin yung negative, lagay mo ng negative sa labas. So kung nakita mo yung direction ng curve natin is clockwise direction, gusto mong gawing counterclockwise direction kasi ganoon naman talaga yung goal o yung nakasanayan natin. Ang gawin mo lang is something na i-negative mo yun, palitan mo yung sign ng ating curve. So yung movement. So again, negative C means traverse counterclockwise. So pag C, traverse counterclockwise, traverse clockwise naman pag negative C. So paki-ano na lang yun. So hindi ko nasusulat kasi hindi naman siya totally ginagamit. So di naman din talaga na-highlight dito. So gusto ko lang ipakita sa inyo yung idea. So another thing, syempre, besides dyan, so since ganyan yung pagkaka-dictate, so syempre, consider na rin natin yung mga scalar field sa loob. So alam natin na sa loob ng vector field, may mga scalar field tayo. So, ano yung unang scalar field natin? So, let's say, ano yung una? Yung, kunwari, negative C. So, integral along the curve negative C or the something na traverse clockwise direction ng P of x comma y. Okay, dx. Since naka-dx siya, this is just equal sa negative integral along C ng P of x comma y dx. Also, and pag ganyan nangyari, this is just integral traverse clockwise direction of q of x comma y dy. This is just equal sa negative integral ng q of x comma y dy. Okay, so yun yung ibig sabihin. Kumbaga ito yung dalawang definition sa loob niya. Tandaan yung properties number 1 yan. Okay, so next is let's have a theorem. So tinuruan ko kayo mag-change of variable. So, maraming type ng change of variable. It's either nasa cylindrical, nasa spherical, change of variable 2 dimension o 3 dimension using yung Jacobian matrix. Tama, kung naalala nyo siya. So, syempre, dito rin siya. So let's say f of x comma y is equal to p of x comma yi plus q of x comma yj be a vector field. So again, that is a vector field. And let's see be a smooth curve. So lagi pinag-uusapan is smooth curve ha. So let's see be a smooth curve parameterized by x is equal to x of t, y is equal to y of t, a is less than or equal to t, a and less than or equal to b. Suppose that t is equal to a of u, for c is less than or equal to u, less than or equal to t. So nagkaroon ng konting parameterization. So sa loob ng parameter t, nagkaroon pa ng parameterization. So another change of variable, parang ganun yung idea. Such that a is equal to a of c, b is equal to a of d, and a prime of u is equal to greater than 0 rather. On the open interval c, comma d, and that is a of u is strictly increasing on the closed interval c, comma d. Then the integral along the curve c of f of the vector field dot product the derivative of the position vector r has the same value for the parameterization. So again, ito daw has the same value for the parameterization na kung ito yung una natin, so integral niya, pag ito yung una natin, ito yung nakasanayan, ito yung smooth curve parameterization natin. Pag pinalitan ko siya or nagkaroon ng konting change of variable, kung pinarameterize ko naman siya in terms of u, that is equal to x equal to x prime x bar of u is equal to x of a of u, y is equal to y bar of u is equal to a of y of a of u, per c is less than equal to u, less than equal to d. So ibig sabihin lang, si t nagkaroon ng konting change, so si t pinarameterize. So again si x parameterized by t, but si t parameterized by u. So kumaga nagkaroon pa ng another parameterization, so double parameterization. So hindi pala siya totally change of variable. Ganyan gagamitin. So ito yung ginagawa niya. So ang idea lang niya is something na pag nagkaroon pa ng another parameterization, same pa rin yung integral nun pag kinuha natin dun sa panibagong parameterization. Ayun. Okay, so let's have an example para mas maintindihan nyo. So ano ba maganda example pagdating dito? Ang daldal ko talaga. Hindi na natapos-tapos. So kung napansin mo no, hindi ko naturo yung tangent. So I think hanap na example pag nagamit natin. Okay, so let's have an example. So ay luminaw. So evaluate the line integral along the curve c of x squared plus y squared dx plus 2xy dy. So as usual, ayun pa rin ang gamit ko, where c is equal to x is equal to t, y is equal to 2t squared for 0 less than equal to t less than equal to 1. So alam natin yung integral nito. So alam natin yung line integral niya. So alam natin na 13/3 where t is equal to sine u for 0 is less than equal to u less than equal to pi. So kung napansin mo, parameterized na si x and y by t, but t is parameterized by sine of u. So another, nagkaroon siya ng panibagong parameterization. So let's say sulat natin or ano natin yung parameterization niya. So ito yung c, this is x of t is equal to t, then y of t is equal to 2t square, okay, for 0 less than or equal to t less than or equal to 1. So since nagkaroon ng bagong parameterization, ano idea? Where t is equal to sine u, ano ibig sabihin? Papalitan ko lang to ng, yung t, papalitan ko ng sine u. So this is just x of u, or x bar of u, is just equal sa sine u, comma, y bar of u, is just equal sa 2, tapos naka-square, that is sine square of u. Where 0 is less than or equal to u, less than or equal sa pi over 2. So ngayon, ito yung bagong parameterization niya. So hindi ba ko lang. Okay, so gawin natin, kunin pa rin natin yung kanyang integral. So line integral. So same approach gaya nung una nating ginawa. So gamitin natin yung ano idea. Yung idea dun sa ito. So kung paano natin gawin yan. So substitute lang natin yung x of u, x bar of u sa mga yan. Okay, so nakakalito na, ang dami ko ng sulat na naman. Okay, so let's have the integral, hoping magkasya din. So integral along the curve c nung x squared plus y squared, then ito ay dx plus 2xy dy. Okay, so by the way, di ko pa nasulat yung mga x bar of u, no? So let's say yung x bar of u, x bar prime of u is equal to Derivative ng sine with respect sa u is cosine u. Then y bar prime of u is equal to, derivative niyan is simply, ano ba derivative ng 2 sine squared? 2 sine squared u. That is 2, no? So magiging 4. Bababa kasi yung 2. So this is 4 sine u. Derivative ng sine is cosine u. Okay, so meron tayong y bar of u. So again, yung derivative of x with respect sa u, o dx over u, that is simply x bar prime of u. So that is cosine u. Papalitan lahat yun. So palitan ko lang to. So this is equal sa integral. So since bago na yung curve, sinared gagamitin, that is from 0 to pi over 2. Tapos lalagyan ko ng malaking bracket. So una is para sa x squared. So para sa x squared, we have sine u. So this is sine u square plus y squared is simply, ito yung, ang y natin is something na 2 sine squared u. So magiging 4 sine to the fourth. 4 sine to the fourth of u. Tapos dx, that is cosine u. Okay, then plus 2xy. So 2 times sine u. Tapos 2 sine square of u. Tapos y bar prime of u. So that is 4 multiplied by 4 sine u cosine u. Tapos bracket. So this is du. So yung huli syempre is du. Okay, so yan, simplify natin yan, no? So pag sinimplify, ano ba magiging simplification nito? So kung napansin nyo, parehas naman silang may cosine u at may cosine u. Pa-factor out ko na lang siya sa buo. So ang mangyayari, this is sine squared u plus 4 sine squared u. So simplify ko lang Integral from 0 to pi over 2. Tapos naka-bracket dito si, sorry, hindi ko na pa-bracket. Solve ko na. So this is sine squared u plus 4 sine to the fourth u. Tapos dito, 2 sine u times 2 sine u square, that is 4 sine to the third, to cube, no, parang cube. Times, ayun pa, isa pang sine. So 2 times 2 times 4, that is 8. So that is to the fourth. So that is plus 8. Diba? 2 times 2 times 4. So check ko lang 2 times 2, 4 times 4, 16. Ayun na, tungak. So this is 16 sine u to the fourth u. Tapos labas ko yung cosine na isa. This is cosine u. So again, saan ang galing cosine? May cosine u dito, may cosine u doon. Factor out ko yun. Tapos ito ay du. Okay, so let us integrate yan. Okay, sorry, hindi pa pala. So this is integral from 0 to pi over 2. So pagsamahin ko na lang, no. So this is sine squared u cosine u plus 20 sine to the fourth u cosine u du. So kung napansin mo, this is u du, parang u sub. So where u, ano yung u natin? Ang u natin is si sine. Ang du natin ay si cosine u. Kasi this is cosine u du. So naulit, u is equal to sine u, du is equal to cosine du. So db na lang, b and db. Assuming nag-b sub tayo. Okay, so since alam ko by power rule, so something na kung naalala mo paano mag-integrate ng ganitong part, so barang power rule lang lumalabas. So sine squared u cosine u, since alam ko na ma-attach yung du dyan, so that is sine cube u over 3 para dito. Dito naman 2 sine to the fifth over 5 kasi kakaroon na 20 pala, no, so over 5. So this is just equal sa, ang una is sine cube u over 3 plus 20 over 5, so that is 4 sine to the fifth u. Tapos yung parameter is from 0 to pi over 2. Okay, so kung papansin mo, pag pinatan natin yung sin pi over 2 is 1. So we all know that sin pi over 2 is simply 1. So parang pag pinalit natin yung sin pi over 2, that is simply 1 cube over 3 plus 4 times 1 raised to 5 minus sine 0 is 0. Sine raised to 5 of 0 is just 0. So this is just 0. So therefore, the answer is just 13 over 3, which is just the same also. Okay, so parehas pa rin nung ating ginagawa or nung last time. So ayun. So ayan yung ating theorem na yun. So now let's have another definition, no? So ang mga ginagawa natin actually is something na hindi close yung curve. So kung napansin mo naman, hindi close ito. So hindi close yan. Ito close pero ibang curve yung pinag-usapan. So kung yung totality, close yan. Pero since yung una sunod natin by straight line, pangalawa is by parabolic line, hindi siya close curve. Okay, so ayun yung mga unang ginawa natin. So hinahanap ko lang yung mga sinod ko pa. So ayan lang naman. So ngayon, let's have a definition. Paano pag close curve? Ano ba yung close curve? Okay, so dito tayo. So by a closed curve, we mean a curve C whose initial point and terminal point are the same. So tama naman, no? Pag sinabi mong closed curve, meaning kung saan ka nag-umpisa, babalik ka lang doon. Yun ibig sabihin. So, and that is for C is equal to X is equal to X of T, ito yung parameter niya, Y is equal to Y of T, and A is less than equal to T, less than equal to B. We have this vector. So we have this vector or points. So X of A, Y of B, Y of A is equal to X of B, Y of B. So, yung parameter niya, instead na X of T, so, ano nangyari? X of A, Y of A is equal to X of B, Y of B. So, for example lang, nag-start siya sa 1, 2, pagbalik niya sa 1, 2 pa rin. So, umikot yung curve. Okay, so, let's say ito yung una. So, in this figure, nakita mo, closed versus non-closed curve. So, ito yung closed. So, nag-start siya sa T is equal to A and B. So, that is, doon nag-start. So, kung napansin mo, ang galaw niya is clockwise direction. So, ang movement niya is pa ganun, pabalik dito. So, bumalik siya. That is a closed curve. Bumalik siya sa terminal niya. Next is something na ganito. So, yung terminal is equal to A, bumalik na sa terminal is equal to B. So, equal lang sila actually. So, A is equal to B. So, dito naman, nag-start sa terminal, T is equal to A, gumalaw siya, up to the point na umabot sa T is equal to B, hanggang dito. So, kung napansin mo, hindi siya close, hindi bumalik. Okay, yan yung idea ng pagiging close. Now, meron pa tayong tinatawag na isa pang klase. So, a simple closed curve is closed curve which does not intersect itself. So, ano naman ibig sabihin na itong simple closed curve? Ito ay simple closed curve actually. So, hindi niya in-intersect yung sarili niya. Ano yung masasabi kong close pero not simple? Yung close, not simple is something na nag-start dito. Ganyan. So, assuming nag-arrow dito, tapos nag-arrow dyan, bumalik. So, ito ay closed curve but not simple. Again, closed but not simple. But not simple. Why? Kasi nagkaroon ng intersection sa sarili niya. Okay, so yun ang idea. Now, a simple closed curve is a closed curve which does not intersect itself. So, tama, ito ay a simple closed curve. Ito ay closed curve but not simple. So, ang idea nun, so pag alam mo na siya ay closed curve, ano gagawin natin? Pag siya ay simple closed curve, ang integral natin ng isang vector field or ng isang real valued or ng isang scalar field is something na different. So kung napansin mo, ang notation natin una is something na ganito. Ang notation natin is integral lang, so walang ibang drawing, kumbaga integral sign lang. So nagkaroon dito naman, so yung idea na to, pag alam mo na siya ay simple closed curve, ang integral niya is something na ganyan, may circle. Okay, so kung napansin mo, ibig sabihin yan, simple closed curve. So pag ganyan yung ginawa ko integral, so pag binahanap ko yung integral niya along the simple closed, so pag alam ko na yung curve is a simple closed curve, ang gagamitin kong notation is something na ganito. Although parehas lang naman ang idea. Again, baka isipin mo, sir, iba gagawin yan? Hindi. Iba lang yung curve. Ibig sabihin lang niya, ang notion lang niya is something na yung curve ko is a simple closed curve. So meaning walang intersection within sa akin at bumalik yung terminal sa initial side ko ay iisa. So pag sabi, ito ay para sa scalar field or the real valued function. So again, scalar field or real valued function, or ito naman siya para sa vector field. So dalawa kasi pinag-uusapan natin, so baka kasi na ang pinag-uusapan natin sa topic na to sa line integral is yung line integral pag scalar field or real valued function, tapos line integral pag vector field. Okay, so which is gumagamit tayo ng dot product. So ayan yung notion. So some book pa rin gumagamit din sila ng may ibang book kasi ganito ginagamit. So minsan ginagamit nila ganitong symbol. So integral so lakihan ko lang. So nagkaroon ng ganyan. So may arrow, kumbaga parang may arrow. Ito ay parang integral, close integral. Tapos ito yung isa, close integral. Line integral, sorry. Line integral. Integral traversing a closed curve. A closed curve in a counterclockwise direction. Counterclockwise. Okay, so similar manner pag pinalitan ko, so ito rin yung isa, yung integral, pagpabalik yung arrow, dito naman yung arrow. So see. So line integral of a closed curve. So line integral of a closed curve in a clockwise direction. Traversing in a clockwise direction. Line integral traversing a closed curve in a clockwise direction. Yun yung arrow na yun. So zoom ko konti para makita mo. So sorry hindi ko makita. Hindi ko mapakita. So again, this is a clockwise direction. May arrow na ganyan. Ito yung isa. So ang hirap kasing i-drawing. So actually. Okay, so let's move on. So sabi nga nito no, let's have a theorem. So may idea yan. So ito yung kagandahan pag simple closed curve. So sometimes yung ganyang idea nagkakaroon ng pampadali. So ang sabi na, let's have a theorem 4.2.2. So in a region R, the line integral. So again, in a region R, the line integral along C of f dot product dr is independent. So again, the term independent of the path between any 2 points in R if and only if the line integral traversing a closed curve f dot product dr is equal to 0 for every closed curve C which is contained in R. So ano ibig sabihin ng pino-point out ni Sir dito? Independent of path of any 2 points in R. So something na, for example, may dalawang curve. Kaya kasing i-ano na ito. May dalawang point. So assuming ko may dalawang point ako. Assuming may P1 ako. So this is P1. Tapos mayroon akong P2. So ito yung ating point na dalawa. Okay, so let's say ito yung una. Yung curve C1, tapos yung curve C2. Okay, so napansin mo, yung curve C1, ang direction niya is from P1 going to P2. So yung terminal side niya is P2. Ang point C2 point niya is from P2 up to P1, yung direction niya. So kung napansin mo, ang tawag dito is independent. So there are path independent. Why? Ang integral ng buong curve, so assuming yan yung buong C, ang integral ng buong curve along dr is equal to 0. So bakit? Ang idea kasi nun is something na pag integrate mo dyan papunta dito, plus integral nito papunta doon, babalik lang as 0. Kumbaga parang negative direction yung isa. Kung napansin mo naman, parang negative balik ta rin ko yung idea. 'Di ba? Ito yung integral papunta doon, tapos ito yung direction, sorry. So assuming ang integral papunta doon, tapos integral papunta rin doon, pabalik din. Okay, so yung direction niya is counterclockwise, direction nito is clockwise direction. So ang mangyayari, pag kinuha ko yung integral kasi along C2 plus integral along C1. So since alam ko na yung C2 is something negative, so lumalabas na ito ay something negative. Okay, so ang totality ng integral is something 0. Ngayon, ito yung idea, ito yung sinasabi ng theorem na to. Pag yung integral niya along the curve C, along the closed curve C of f dr is equal to 0, ang tawag sa kanya is path independence. Okay, again, the line integral is independent of path or path independence. Ano ibig sabihin na path independence? May integral siya dito, may integral siya doon. Okay, so kung kunin ko yung integral papunta doon, kung papunta lang doon, may integral siya as a. Pero pag yung integral ko kinuha balikan, nagsasalubong, yun yung meaning niya, yun yung meant to be net, yung meant nito. So pag nagsalubong, that is magsi-0. Pero pag pabalik doon, okay, so yun yung ibig sabihin na pagiging path independent. So as long as yung integral na FDR is equal to 0. Now, let's have the chain rule. So paano naman gumagana yung chain rule dito sa ating vector field saka line integral. So paano gumagana yung sa line integral yung chain rule? So let's have theorem 4.2.3. So if z is equal to f of x comma y is a continuous differentiable function of x and y, and both x is equal to x of t and y is equal to y of t are differentiable function of t. So meaning differentiable, nag-exist yung derivatives, hindi undefined yung derivative. So then c is differentiable function of t. So, and the derivative of z, so since ito yung z, the derivative of z with respect sa t is just equal sa partial derivative of z with respect sa x times dx over dt. So, I think naayos ko sa inyo yan. So, sa akin kasi hindi ko naayos. So, dt yan. Plus, partial derivative of z with respect sa y, dy dt. At all points where the derivative on the right are defined. So, napakadali at napakasimple lang naman ng pinupoint out niya. So let's say meron tayong z is equal to x squared y plus xy. So pag kinuha ko yung dz dt, so this is a chain rule. So this is just equal lang sa partial derivative nung z. So partial derivative nito, partial derivative of z with respect sa x. So partial derivative nito is just 2xy plus y. Tapos lagay ko lang dito yung dx over dt. Then plus partial derivative of z with respect sa y, so that is simply x squared plus x, then this is dy dt. Okay, so ganun siya kasimple. So ayan lang kanyang pinaka chain rule. So ano yung dx over dt? That is x prime of t. So similar case, that is simply x prime of t. This is y prime of t. So or it can be written as 2xy plus y, this is x prime of t, plus x squared plus x, this is y prime of t. So this is the chain rule. So this is the way paano natin gagamitin yung chain rule. So actually wala naman akong definite example para sa chain rule. So that is a theorem lang. So pinakita ko lang talaga sa inyo paano nangyayari dito yung chain rule. Okay, so now let's have another example. So kung napansin mo, sa integral meron naman tayong tinatawag na definite integral. So sa definite integral, so I think that is second fundamental theorem of calculus. So ano yung second fundamental theorem of calculus? If f is a continuous function with antiderivative f. So tandaan ko lang ha. So ito yung pagkakaalala ko. If f is a continuous function with antiderivative capital F, then the integral from a to b nung f of x comma y is equal to f of b minus f of a, kung naaalala nyo. So f of a minus f of b. So meaning yung antiderivative evaluated by the upper function or upper boundary minus the antiderivative capital F of the lower boundary natin, which is a. Ganun yung ginagawa. So meaning meron din siya dito actually. So, yun nga, no? So, let's have theorem 4.2.4. So, let f of x comma y is equal to p of x comma y I plus q of x comma y j be a vector field in some region R. So, again, gumagana lang si theorem 4.2.4 sa isang vector field. So, with p and q continuously differentiable function on R. So, let C be a smooth curve in R parameterized by x is equal to x of t and y is equal to y of t. For a is less than equal to t, less than equal to b. Suppose that there is a real valued function f of x comma y, capital F of x comma y. Kumbaga, na-integrate mo. Ngayon na idea. Suppose na na-integrate mo siya. So, ano yung, actually, ginagawa na natin siya sa mga example natin kanina. Although, check ko lang. Nakakalito, madami na akong ginagawa. So, makikita na lang din. So, ginagawa naman na siya actually. Now, suppose that there is a real valued function f of x comma y such that the gradient of f is equal to the vector field. So, ano naman yung gradient of f? So, kung naalala mo, the gradient of f is simply that is the partial derivative of f with respect sa x, comma, partial derivative of f with respect naman sa y, kung 2-dimensional. So, since 2-dimensional tayo dito, ayun ang sagot. So, on R, then, the integral, so, ayun get the line integral of the vector field f, dot product dr, along the curve C, is equal to f of b, minus, sorry, minus yan, hindi ko na bago. So, try kong baguhin sa inyo. F of b minus f of a, where a is equal to x of a, comma, y of a, and b is equal to x of b, comma, y of b, are endpoints of C. Again, endpoints. So, kung alam mo yung endpoints, given yung endpoints, pwede mong gamitin yung theorem na to. Tandaan, kung given yung endpoints, gamitin mo tong theorem na to, bahala ka. Thus, the line integral is independent of the path between its endpoint. So, yun nga, independent siya kasi dalawang yan independent. So, now, since it depends only on the values of f, those are those endpoints. Now, remark, a real valued function f of x, comma, y such that the gradient of f of x, comma, y is equal to the vector field x of x, comma, y is called a potential for f. Again yung f of x, comma, y ang tawag sa kanya potential of f, of the vector field f. Yung f of x, comma, y na mahanap mo, ang tawag sa kanya is potential for f, or the vector field f. Now, a conservative vector field is one which has a potential. So, ang tawag naman sa vector field na may potential vector is a conservative vector field. So, huwag kayo malilito sa dalawang term na yan. Yung capital F of x, comma, y, potential yon. So, potential for vector field f siya. Ngayon, pag nangyari yan, pag yung gradient ng potential vector natin is equal to the vector field, ang tawag sa vector field natin is a conservative vector field, is one which has potential. So, yun yung sinasabi dyan. So, now, let's have an example. So, balikan ulit natin yung example. Apply ko muna tong theorem na to. So, mamaya na yung potential saka conservative vector na yan. So, para makita nyo rin paano mag-solve at paano maghanap ng potential vector for f. So, let's have an example. So, example, the integral of C, evaluate the integral along the C of x squared plus y squared dx plus 2xy dy. So, actually, not just the integral, the line integral of x squared plus y squared dx plus 2xy dy along the curve C, where C is the polygonal path from 0, 0 to 0, 2 to 1, 2. Okay, now, balikan natin yung graph nito. So, kung napansin mo yung graph nito last time is something na ganito. So, starting siya sa 0, 0, tapos nag-end siya somewhere dito sa 1, 2. Kung napansin mo, yung buong curve, yung buong totality ng curve, so, ang approach natin dito is something, sir, ang ginawa ko po is, kinuha ko po yung integral along C1 plus integral along C2, o yung line integral along C1, then along C2, then inad. Okay, now, gamit yung theorem 4.2.4, kukunin natin yung dalawang endpoints. Ano yung dalawang endpoints na? Yung 0, 0, saka 1, 2. So, yun na yung gagamitin natin now. So, paano natin gagawin yan dyan? Check ko lang So, ang goal natin is syempre hanapin natin dito yung ating function. So, ang goal natin is hanapin natin dito yung conservative vector. So, actually, gagamitin pala natin dito. Tapos, saka natin gagamitin yung theorem na to. Okay, so, paano ba natin nahanapin yung function na yan? So, ang goal natin is hanapin natin yung f of x, comma, y. Yung f of x, comma, y. So, our goal, find capital F of x, comma, y, the potential for f, or the vector field. So, paano natin nahanapin yan? So, aware tayo na ang sabi ng definition, ako ay magiging potential pag yung aking partial, pag ito ay nangyari. So, potential vector ako pag yung partial derivative of f is equal to f. Okay, so note, ano yung gradient? Gradient. Ano yung gradient of f of x, comma, y? Ang gradient na to is just ganito. So, this is partial of f with respect sa x, comma, partial of f with respect sa y. So, ito yung gradient, which is equal sa, ano ba yung component natin? So, kung naaalala mo, ito ay just equal lang sa, ito yan, x squared plus y squared dx, 2xy plus dy. So, kung napansin mo, ito ay can be written as ganito. It can be written as x squared plus y squared, 2xy. So, ito yung para sa f of x, ito yung para sa dito. Tapos, naka-multiply kasi yan dito sa dr. Okay, so dr, d prime of r. So, pag dinot product rather. Pag dinot product mo yan, ito yung kakalabasan. Okay, so anong nangyari? Biniyak ko lang siya, binalik ko lang sa una. So, that is x squared plus y squared, 2xy. So, this is just x squared plus y squared, 2xy. So, kung napansin mo, may dalawang klase dyan. Partial derivative of f with respect sa x is equal to x squared plus y squared. Okay, so next is partial derivative of f with respect sa y is equal to 2xy. So, ayun, nahanap na tayo ng potential vector. So, paano natin nahanapin yung potential vector natin? So, ganito yan. Kung napansin mo, ang goal natin is hanapin yung f. Again ang goal natin is hanapin yung capital F. So, paano natin tatanggalin yung capital F dito? Since ang idea nito, this is the partial derivative of capital F with respect sa x is equal to x squared plus y squared. Meaning, i-integrate natin siya. So, from this, so lagay ko lang, so this is the integral of partial derivative of f with respect sa x, tapos dx equal sa integral ng x squared plus y squared times dx. Ganun, from here naging ganito kasi gusto ko matanggal. Now, pag in-integrate ko yung partial of f with respect sa x, partial of f with respect sa x dx, this is just equal sa f of x, y, or simply f, which is equal sa, anong gagawin natin dito? Ang integral na ito with respect sa dx is just x cubed over 3 plus y squared x. Now, may dadagdag ako. This is plus g of y. Ngayon, paisip kasi bakit po may g of y? Ito ang idea. This is just something, tawag dito, indefinite integration. So, nangyari lang is just we apply dx both side, we apply integral both side, then naglagay tayo ng dx as the differential niya. So, nag-integrate tayo. So, ang idea is something na i-differentiate or i-integrate natin siya with respect sa x. So, ano nangyari? The integral of x squared with respect sa x is x cubed over 3. The integral of y squared with respect sa x, integral of y squared dx is equal to y squared x plus g of y. So, bakit meron nakalagay na g of y? Ito lang ang idea ko. Pag dinifferentiate ko siya or pinartial derivative ko siya with respect sa x, ano mangyayari? Ang partial derivative ng x cubed over 3 with respect sa x is x squared. Ang partial derivative ng y squared x with respect sa x is just y squared. Ang partial derivative ng g of y, ano yung g of y? That is a function of y. So, ano ibig sabihin ng function of y? Function of y meaning puro variable y. Something na y squared plus y plus 3. That is a function of y. So, meaning, ano ang partial derivative niya with respect sa x? 0. Mawawala. So, yun yung idea ng sinasabi ko dito. So, kaya nagkaroon ng g of y. That is a function of y. Again, a function of y. Kasi wala akong nakikitang y dyan. So, similar case dun sa gagawin ko dito sa isa. So, let's say, integrate naman natin si f. So, partial with respect sa y. Tapos, dy. This is just equal sa integral ng 2xy. Then, this is just dy. So, pag in-integrate, this is f of x, y is equal to, with respect sa y, so this is something 2xy squared over 2. So, this is simply xy squared plus, ano naman lalagay ko dito? Ang lalagay ko naman dito is something na, ang tawag ba dito? Check ko lang Okay. So, ayun, paki-delete to. So, hindi ko na kailangan palang i-apply to. So, tandaan mo magkakaroon ka lang ng partial differentiation or ng partial integration dun sa una. So, actually, either naman sa dalawa. Pero, mas better dito. So partial derivative of f with respect sa x. So, doon ka lang magkaroon ng partial integration. So, after nyan, ayun yung nangyari. Okay? So now, consider natin tong part na to. So sabi na yung partial derivative of f with respect sa y is equal lang sa 2xy plus g prime of y. Okay, so again kung ito yung f of x comma y is equal to x cubed over 3 plus y squared x plus g of y, ang partial of f with respect sa y naman is equal to 2xy plus g prime of y. So, sir, bakit g prime of y? So, assume na derivative ko siya. So, this is only true. Ito is parang sinasatisfy niya. Satisfies, lagay ko lang satisfies yung partial derivative of f with respect sa y which is equal sa 2xy if yung g prime of y is equal to 0. Okay, so g prime of y is equal to 0. Ngayon, kailan magiging yung g prime, so again fix na ipa-partial derivative ko yan, magkakaroon ng g of y. Tapos after nun, yung partial derivative of f with respect sa y is simply equal sa 2xy plus g prime of y. Tandaan, fix yan sa solution na to. So magkakaroon siya diyan. Ngayon, isa-satisfy niya yung partial derivative of f with respect sa y of e is equal to 2xy if g prime of y is equal to 0. So magiging equal sila, ibig sabihin nun pag yung g prime of y is equal to 0. Ngayon, kailan magiging g prime of y is equal to 0? Again, kailan magiging g prime of y is equal to 0? That is when, tayo ko lang dito when g of y is just equal to k, which is a constant. Okay, so tandaan ulit, kailan magiging g prime of y is equal to 0? Magiging g prime of y is equal to 0 pag yung g of y natin is a constant k. So meaning number na siya. So fix ko na instead na 2, 3 siya, magiging number siya. So which is 4, 7, pi or something. So walang variable y dyan. So yun yung mag-satisfy. Ngayon, since ganun yung mangyayari, since alam ko na constant siya, we pick. So again this is a fix. So we pick or we choose that k be equal to 0. Since alam ko naman since constant siya, wala naman siya magiging direct effect sa ating function. Wala naman siya magiging, alam kong constant siya, yung g of y na yan, constant lang yan. Pag in-integrate ko pabalik o dinifferentiate ko babalik lang siya sa dun sa original function. Wala siyang magiging epekto. Ngayon, therefore, ano yung potential natin? Therefore, the potential for f, the vector field f is f of x comma y which is equal sa 1/3 x cubed plus x y squared. So that is the potential. Okay, so ayun pa lang yung potential natin. So now, since nahanap na natin yung potential, apply na natin si theorem 4.24. So sabi niya, pag meron akong f which is the potential, so anong gagawin lang? Isa-substitute lang natin yung endpoints which is B and A. So ano yung endpoints natin dito? Ang endpoints natin dito is something na yung A natin dito is 0, 0. Yung B natin dito is just 1, 2. Okay, so by theorem 4.2.4, so sana magkasya 4.2.4. Yung integral, so lagay ko na lang yung line integral ng f dr is just equal sa f of 1, 2 minus f of 0, 0. Kasi ito yung f of a, f of b minus f of a. Ano yung value na yun? Anong gagawin? Papalitan ko lang yung ito yun. So x cubed plus x squared minus 1. So this is just equal lang naman sa 1/3. Ito ay 1 cube plus 1 times this is 2 square minus this is 1/3 times 0 cube plus 0 times 0 square. So tama, kumbaga in-apply ko lang yung 1, 2 dun sa potential vector natin, tapos yung 0, 0 dun sa potential vector natin, which is pag sinod nyo, that is simply 1/3 dito, then dito ay 13 over 1/3 dito, tapos 4. So 1/3 plus 4, this is equal lang sa 4. So this is just equal sa 13 over 3. Okay, which is the same. Okay, so ngayon, paano gagawin mo? Kung gagamitin mo si theorem 4.2.4, pag given, ito again, applicable lang to pag given yung endpoints. So pag alam mo yung endpoints niya, Kung gusto mong gamitin yung theorem 4.2.4, anong gagawin mo? Hanapin mo yung potential f o yung the potential vector f using this method. Again, using this method, then after mo mahanap yung potential vector, apply mo yung theorem 4.2.4. Then, substitute mo lang yung mga values or the endpoints. Therefore, that is the line integral. Okay? So now, let's have this example again. So, corollary, if a vector field f has a potential in region R, then the integral along the simple closed curve of f, dot product dr is equal to 0 for any closed curve C in R. So, that is the integral of the closed curve of the potential. So, tingnan mo, yung f na yon equal sa potential vector. Yung f na yon is equal sa gradient ng potential vector natin times dr is equal to 0 for any real valued function. So, tama naman. Alam natin na yung f is equal to the gradient of capital F o the potential vector. So, palitan ko lang nun, this is just equal dito. So, times dr is equal to 0. So, for any real valued function, f of x, y. Another thing din pala. So, ano idea ng potential vector? Si vector field, meron siyang equivalent scalar field or simply equivalent real valued function, and that is the potential vector f. So, ayun nga, sabi na, for any real valued function f of x, y. So, from being a vector field, ginagawa ko siyang real valued function. So, kaya natin gawin yon. So, from vector field, kaya mo siyang gawing real valued function or scalar field. Okay, so let's have an example ulit. So, try pa natin solve to, no? So, try natin hanapin yung potential vector nito, then i-evaluate natin or i-integrate natin siya with respect sa kanyang parameter. Okay, so, try natin. So, ang sabi is, evaluate the closed integral of the simple closed integral of x of dx o the line integral of the simple closed curve of x dx plus y dy for c is equal to x is equal to 2 cosine t and y is equal to sine t. For 0 is less than or equal to t, less than or equal to 2 pi. So, now, hanapin natin yung potential vector niya. So, paano ba hanapin yung potential vector nito, by the way? So, kung napansin mo, ang vector field natin dito, by the way, is, so, solve ko lang Yung vector field natin dito is something na x, y. Tama, kasi x and y yun, x, y, or simply, para siyang x sa component plus y, j. Okay, so ayan yung ating, so ngayon, hahanapin natin yung potential niya. So, f of x, y has a potential f. Has a potential f of x, y. So, the idea is to find the potential f of x, y. So, similar manner or similar approach, ito yung x natin. So, alam natin, aware tayo na yung partial derivative of f with respect sa x is equal lang sa first coordinate which is x. Okay? So, meaning this is just equal sa, pag in-integrate ko siya, so pag nilagyan ko ng integral sign, so this is just equal sa integral partial derivative of f with respect sa x dx is equal to the integral of x dx. Okay, so which is equal sa f of x, y is equal sa x squared over 2 plus g of y. So, fix naman lagi nandyan si g of y. Okay, so now, ano naman yung mangyayari para dun sa isa? Paano naman natin makukuha yung value ng isa natin? Check ko lang nga. So, paano ko ba kukunin siya? Okay, dun para naman sa partial derivative of f with respect sa y. This is just simply equivalent lang sa y. Alam natin yan. Okay? So, alam natin na equivalent lang siya sa y. Which is, ganito yung ginawa. Ganito yung imagine niyo. Ito yung nangyari. Yung partial derivative of f with respect sa y is equal to 2xy plus g prime of y. Naglagay ako o nag-attach ako ng g prime of y. So, meaning, nag-attach ako ng function of y pero differentiable function of y. Okay? So dito, nangyari, meron ng combination o meron ng tawag dito, combination ng x and y. Kumbaga, meron tayong f of x, y na given, which is 2xy. Ngayon, pagdating dito, ang nangyari, ang function of f, yung partial derivative of f with respect sa y, hindi siya combination ng x and y. Again, hindi siya combination, hindi siya function na combination ng x and y. Ngayon, ano gagawin? Aware ako na ito ay simply equivalent lang sa g of y. So, again since wala akong f of x, y na nakikita. Ito kasi alam ko f of x, y ito eh. Okay, kaya nag-attach ako ng plus g prime of y. Ngayon, pag nakita mo lang is something y, so meaning puro y lang yung natitira, that is the obvious thing na siya yung equivalent sa g prime of y. So, yun, buti nakita ko. So, again dalawa yung case para dun sa partial derivative of f with respect sa y. Once na makita mo na yung 2xy na yan, hindi. Pag nakita mo na combination siya ng x and y, so meaning, kunyari, x squared plus y squared, kunyari, ganun yung given, combination pa rin ng x and y yung kahit magkahiwalay. Kunyari, x and y, x over y, combination pa rin siya ng f of x, y. Okay, so meaning, attach mo lang yung g prime of y, tapos yung g prime of y is equal to 0, automatic, tapos gagawin mo siyang constant. Ngayon, since ganito siya, ang nangyari naman is partial derivative of f with respect sa y is equal to y based sa nakuha natin. So meaning, siya ay pure function of y lang. So hindi ko siya pwede consider na function of x and y. Again, pure function of y lang siya. Hindi siya function of x and y. Since ganun siya, equate ko na lang siya as g prime. So i-consider natin siya as g prime. So from there, anong gagawin ko? Yung g prime is i-integrate ko. So from there, integrate ko yung partial derivative of f with respect to y, which is equal sa integral nung g prime of y dy. So which is equal sa integral of y dy. Okay, which is this is just equal sa 1/2 y squared plus ito na yung merong k. So sir, bakit yung g of x? Kasi nga single variable lang naman siya. Again ito, kaya meron akong g of y kasi multivariable siya. Multivariable pa lang siya totality. So, ito x lang naman eh. So, dapat function of x lang siya. Hindi. Ito kasi yung starting ko. Ito yung starting ng solution. Pagdating dito, ito na yung basis. Kumbaga, sa starting, pagdating dito, basis na ako ng solution. Kumbaga, ako na yung magde-declare ng totality ng solution. So, sa akin, check mo ko kung ako ba ay function of y o function ng double variable o ng x and y. Pag hindi, ako na ako consider mo na g prime. Tapos, integrate mo ko with respect sa y. Tapos, pag in-integrate mo ako ay function of y pa rin plus a constant k na. So, gaya nga nung sabi ko, nagkaroon din ng constant k pagdating kay g of y. So, therefore, ano yung g of y? So, ito yung ating g of y. Okay? So, therefore, ano yung ating potential vector? Ating potential vector, yung f of x, y. So, set lang natin. So, yung f of x, y natin is just equal sa 1/2 x squared plus yung g of y natin is just simply 1/2 y squared plus k. So for k is equal to 0, this is just equal sa f of x, y is equal sa 1/2 x squared plus 1/2 y squared. Okay, so ito yung potential for f. So, nagkaroon na ako ng potential for f. Ngayon, ano idea? Ano ba gagawin? So, sabi, since closed curve siya, paano natin nahanapin yan? So, ano ba yung graph ng 2 cosine t sa 1 y sin t? Okay, so now, ito yung potential. Ngayon, ito yung idea. Alamin mo naman kung ano yung itsura ng curve. Kasi ang goal ko kasi, kailangan ko malaman kung close ba yung curve C ko. So, note na yung curve C ko. So, yung curve C ko is equal to x is equal to 2 cosine t. Okay, so, pag ang equivalent nito is just x over 2 is equal to cosine t. So, yung isa naman is y is equal to, so, nakalimutan ko ilagay yung 3. So, sorry may 3 to. So, that is 3 sin t. So, although walang epekto yan. So, this is simply y over 3 equal to sin t. Okay. So, ang gagawin ko, is square ko yan, then add. Again, ito equation 1, tapos ito. Para mahanap ko anong klaseng curve siya. I-square ko both side, tapos i-add ko. So, pag in-square ko yung una, this is simply x squared over 4 is equal to cosine squared t. Pag in-square ko to, this is y squared over 9 is equal to sin squared t. So, pag pinag-add ko, left side sa left side, right side sa right side, this is just simply x squared over 4 plus y squared over 9 is equal to cosine squared t plus sine squared t, which is equal lang sa x squared over 2 square plus y squared over 3 square, which is equal to 1. So kung napansin mo, this is an ellipse. Okay, ellipse na center at 0, 0 with length ng kanyang major and minor axis, which is equal to 3. Ang length ng major axis is 3, length ng minor axis is 3, tapos siya ay ellipse naka-center sa 0, 0. So center at 0, 0. So ito ay center at 0, 0. Ano itsura niya? Ang itsura niya is something na ellipse siya, no? So dito ko na nalagay. So ang itsura niya is something na since y yung malaki, so something na ganito itsura niya. So assuming na 3 to, ito ay 2. Okay, so yan yung itsura ng graph. So napansin mo close siya. Okay, now, since ito yung potential, so sabi ng corollary 4.5, so by corollary 4.5, yung integral along the curve C nung potential o nung gradient ng potential vector, dot product dr is just equal to C. Why? Bakit ulit C? Kasi closed curve C, ellipse. Okay, so therefore, this is just equal lang sa C. Okay, so actually walang point dito, no? So ang goal ko lang, actually dinagdag ko lang kung paano ulit maghanap ng potential vector. So hindi naman talaga goal hanapin si potential vector kasi pwede ko na dictate dito pa lang Ito pwede ko na to So integral along the curve C ng FDR. So ito naman ay nahanap ko na. So nahanap ko na siya ay closed curve. Since nahanap ko na closed curve, alam ko yung integral niya is 0. Okay? So pero syempre kailangan ko lang mahanap. Ang gamit kasi nito, if a vector field has a potential in region R, so since nagkaroon siya ng potential, so since meron akong potential, therefore yung integral niya nung FDR, so or lagay ko lang dito, integral along the curve C nung FDR is also equal sa 0. Pwedeng ito rin naman yung i-conclude ko. So either sa dalawang yan. Okay, so again, ito yung another way ng idea. So from parameterization, kaya ko din hanapin yung curve. So at least may natutunan kang bago. So pinakita ko dito yung paghanap ng potential kasi kailangan. Sabi ng corollary 4.5, kailangan may potential muna. Pag may potential, pwede mong i-dictate. So pwede mong sabihin na 0 siya. So without solving it, alam mo na siya ay 0. Okay, so that's all for this video. Hoping na may natutunan kang mga bago. Actually, ang dami mong natutunan bago dito. So hoping na naintindihan mo kung kailan gagamitin yung mga theorem na to. So again, thank you for watching. Hoping na nag-enjoy ka kahit paano.